Fundamental counting rule. In a sequence of n events in which the first one has case of 1 possibilities and the second event has case of 2 possibilities and so forth, the total number of possibilities of the sequence will be, you multiply how many possibilities for each one together. Now we did this in a previous video called At Least Problems, and we flipped a coin 5 times and we talked about how many items would be in our sample space. And a coin has 2 sides, so the first time you flip it, you have two choices, and then the next time and the third time and the fourth time and the fifth time. Remember that? We were using the fundamental counting rule. So if you look at number 1, a coin is tossed and a die is rolled. Find the number of outcomes for the sequence. Well, how many choices do you have for a coin? 2. How many choices do you have when you roll a die? Well, a die has got 6 sides, so you got 6 choices, so your total possibilities is 12. In problem number 2, it's talking about paint, and the paint is by color, type, texture, and use. How many different kinds of paint can be made if you select one color, one type, one texture, and one use? Well, how many choices do I have for colors? If you count those, there's 7. How many types? 2. How many textures? 3. How many uses? 2. And that's 14. That's going to be 84. Now let's talk about factorials. The factorial concept comes into play in the binomial theorem and in the binomial distribution, and also in combination and permutation problems. Those are also counting formulas. So to define factorial, n factorial is n times n minus 1. Keep on going, subtracting 1 until you get down to 1. So 4 factorial would be, you start at 4, decrease by 1, decrease by 1, decrease by 1, and multiply those together and you get 24. Permutation. With a permutation, order matters. And a permutation may be written in the form NPR, and that's n items, choose R at a time. Or you may see it like this, PNR. But the formula is n factorial divided by n minus R factorial. Order matters. Number 4. A radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guest is important, so it matters. How many different ways can this be done? So you got 6, choose 3. 6 permutation 3, and that will be 6 factorial over 6 minus 3 factorial. And that's 6 factorial over 3 factorial. Watch how I do this. I'm going to write the 6 factorial out, but I'm going to stop at 3 factorial so I can cancel the 3 factorial in the denominator. So I'm left with 6 times 5 times 4, and that's 120. Order matters. Combination, order does not matter. And you can write as combination n choose R, combination n choose R, and this will be n factorial over R factorial times n minus R factorial. An advertising executive must select 3 different photographs for an advertising flyer. If she has 10 different photographs that can be used, how many ways can she select 3 of them? Doesn't say anything about order mattering. So it's going to be a combination 10 choose 3. So that's 10 factorial divided by 3 factorial times 10 minus 3 factorial. That's 10 factorial over 3 factorial times 7 factorial. And I'm going to write out that 10 factorial, but I'm going to stop at 7 factorial. 10 times 9 times 8 times 7 factorial over 3 factorial, which is 3 times 2 times 1. I'm going to leave the 1 off. 7 factorial. Cancel, cancel. 2 will go into 8 4 times. 3 will go into 9 3 times. 3 times 10 is 30. Times 4 is 120.